Today in this lecture, we will discuss in more detail about the IV characteristics of PN junction. As we discussed in the previous lecture about the diode, diode is such like device which is made by the N-type material and P-type material under high pressure. Under high pressure, the PN junction will be formed. Inside this junction, we have the immobile ions. Towards the N-type material, we have the positive immobile ion, and towards the P-type material, we have the negative immobile ions. Okay, these ions here inside this PN junction, we have no free electrons or hole, so therefore we call this as a depletion layer. This layer, these negative charges provide the potential barrier to these negative charges in order to cross this depletion layer. Similarly, we have these positive immobile ions provide the potential barrier to these positive holes in order to cross this PN junction in order to cross this depletion layer. Okay, so if we provide the battery, external battery, to this diode, okay, and if we connect the negative terminal of the battery to the N-type material and positive terminal to the P-type material, and if we increase the voltage from here, okay, this negative as connected with the N-type will repel these majority charge carrier as electron. And similarly, we have this positive charge, and here on the hole we have the positive charge, and this positive terminal of the battery as a anode here will repel these positive charges towards this depletion layer. So instead we provide the battery here. There will be no current inside this device. This is because of this potential barrier inside this depletion layer. So the experimental graph of the external voltage, which is represented on x-axis here, and the current inside this device is represented on y-axis. Okay, so if we increase the voltage, there will be no current. Here from the graph, if we increase the voltage, the current is zero because of this potential barrier. Okay, so if we increase the voltage up to here, from here to here, if we increase the voltage, the small amount of the current will begin, and if we increase the voltage, that is increasing, and if it reach here to this point, the current will be suddenly increased, and now this material will behave as a conductor. Now it will not remain as a semiconductor material. So above this voltage, it will behave as a conductor. Okay, so what this voltage after which the current has increased abruptly is called the knee voltage or cut-in voltage. For silicon, it is about 0.7 volt, and for germanium it is about 0.3 volt. It means that if this crystal is made up of this, if this chip is the silicon chip, and on top of it we have made the N-type and P-type material, then this depletion layer, so in that case, this depletion layer will have some electric field from this positive charge to this negative charge. That this is actually the positive, this is the negative charge. So here we have some potential. Okay, in silicon, this potential is about 0.7 electron volt. So in order to make this electron to flow from to cross this potential, we will have to provide 0.7 electron volt to this electron in order to cross this potential barrier. So we are going to provide the 0.7 electron volt to this free electrons. Then here the electric field and the potential will be cancelled with the external battery, the external potential, and in that case the electron will suddenly start motion and will recombine here with this hole, and this device will now behave as a conductor. Okay, so if we provide, let's say, if this is made up of the silicon, and if we provide 0.2 electron volt, there will be no current. If we increase that to 0.3, 0.4, 0.5, 0.6, there will be no current. So from the 0.5 it will start minor current here, because from here if we increase it to up to 0.5, the small amount of the current will be stopped. That is due to the hopping of this electrons from this side to this side. Okay, and here that will be recombined and the current will be start, and that will be minor, very less. Okay, so if we increase this up to 0.6, that current will be increased and as compared to the previous. So here if we increase that up to 0.6, that current has increased with this voltage. But if we reach the 0.7 electron volt of this battery, that will cancel this 0.7 electron volt of this potential barrier. Then these all electron will start motion towards this p-type and will combine with these holes. So the current will start in this device, and this device will behave as a conductor. So this is that 0.7 electron volt. So up above that, if we provide the external battery this voltage above that, this device will behave as a conductor. Okay, so on the other hand, if this material is made up of the germanium, so the germanium have this new voltage is 0.3. okay, so if the external battery have 0.1 voltage, then there will be negligibly small current due to hopping. If we increase that to 0.2, the current will be increased as compared to the original. But if we reach the 0.3 or exceed that, then large number of the charges will so in that case this depletion layer will be finished, and in that case this potential barrier will be vanish, and in that case these all electrons will jump and recombine with this hole, and this device will behave as a conductor. Okay, so we have that case. Okay, and during that forward biasing, if this battery exceeds 0.7 in case of the silicon, if this battery exceed that up to 0.7, this depletion layer will be here this depletion layer will be vanish. Okay, and there will be no potential barrier upper to these electrons, so these electrons will easily recombine with these holes, and due to which the holes will be moved in this direction, the electron will be moved in that direction, and this device will behave as a conductor above this knee voltage. Okay, now we have the reverse bias. If we connect the positive terminal of the battery to the n-type material and the negative terminal of the battery to the p-type material, so here this is the positive terminal, and these are the here the charge carrier, the electrons are majority charge carrier which have the negative charge, so this positive charge will attract that negative charge towards itself, and these electrons will be attracted towards this towards this. Okay, and similarly we have this negative charge and we connect that with the p-type material. P-type material have the hole as a majority charge carrier, that all holes will be attracted towards this okay, towards this side, and due to which that depletion layer will be increased, because these electron has attracted towards this side, these holes has attracted towards this side, due to which this depletion layer will be increased. Okay, so if we increase this voltage from the battery, what will happen to the current here in this case? Okay, what will happen to the current? So the experimental graph for that is given by this is actually the IV characteristics for that. I is the current, V is the voltage in the x-axis, and now it has reversed. Okay, this is the negative. Okay, so because here this is the reverse bias. Now if we provide less voltage, such a less reverse voltage, okay, I mean that if the magnitude is less, okay, then there will be less current because of this motion of the electrons towards these plates. Okay, so that current is represented here. If we increase this the magnitude of this voltage, some voltage will be so this device have some this device will bear some electric field. So if we increase this voltage, this external voltage, these immobile ions will be more, due to which the electric field inside this PN junction, this depletion layer will be more. So if that electric field is more here, these immobile ions are actually the atoms. That atoms also consist of the other electrons. Okay, that are that not a pre-electron, but it still consists of the electrons. Okay, and here we have that field which is provided by the battery. So due to that field, the electrons from that these atoms will be moving in opposite direction towards the electric field here. Due to that electric field, that electron inside these atoms will be knocked down from these atoms. Okay, so due to which the current will be start. Okay, so if we increase the reverse voltage, the current will be increased in the reverse direction here. Okay, the current will be increased due to this motion of these charges, and here the electric field will be increased. So this is that last limit of this device up to which it bear the electric field. It bear that voltage. Okay, so that voltage up to which it bear is called the uh, peak inverse voltage. So the maximum voltage that the rectifying diode has to withstand when it is reverse bias is called the peak inverse voltage. So if beyond that peak inverse voltage, if we increase this the magnitude of this external voltage, then the electrons inside these atoms will be knocked out. Okay, and that due to that knockout electron, the current will be increased. Okay, so that effect due to it the current is increased, that effect is called the Zener effect. Okay, in the reverse bias, if voltage is increased due to available energy, covalent bond will be break inside this the covalent bond will be break between these immobile ions. Okay, and large number of electrons are released. This cause a sudden increase in a current. Okay, this effect is called the Zener effect. If still we increase the voltage, the magnitude of the voltage, that knock the energy of the kinetic energy of that not knock the electron will be more, and that will be collide with the neighbor, the electrons of the neighbor atoms, and due to which the electron will be more. Okay, due to which the current will be more again. Okay, that effect is called the avalanche effect. Avalanche effect is that this also occur in this reverse bias. So in the reverse bias, if reverse bias is increased further, if we increase the voltage of this battery further, minority charge carrier attain high velocity. Here that charges that knocked electrons which is produced due to high voltage will attain the high velocity. Their kinetic energy will be increased, and knocked and due to that electron will be collide with the neighbor atoms, the electrons of the neighbor atoms. Okay, uh, and uh, and due to which it knocked down the bonded electron of that neighbor atoms from the covalent bond. Due to that collision, and the current will be increased further. This sort of the effect is called the avalanche effect. Okay, so I am going to quickly recap this. In reverse bias, if we provide the voltage, the battery, and if we increase the voltage, the current will be increased. The current will be increased. Okay, there will reach a voltage beyond that, if we increase the this there must be the voltage which is bear by this device. So beyond that, this device will change their behavior. That voltage is called the peak inverse voltage. So if we increase this magnitude beyond that peak inverse voltage, the Zener effect will be occur. Zener effect is actually that Zener effect is actually occur due to that electric field. So if we increase the magnitude of this battery, the electric field will be increased here. Due to that electric field, the electrons will be knocked from the covalent bond of these immobile ions, and due to which the current will be increased. That effect is called the Zener effect. And if beyond that, if we increase the battery, okay, the magnitude of this provided voltage, then that knocked electron will the kinetic energy of that knocked electron will be increased further, and it will it will remove the covalently bounded electron of the neighbor atom, and will increase the current further. This effect is called the avalanche effect. Okay, so here we have that this is the forward biasing. In forward biasing mode, the IV characteristic. This is in reverse biasing mode, the IV characteristic. So in forward bias, if we increase the voltage, the current is 0 up to here. From here it is increased, and this is the new voltage. Beyond this, the device is behave as a conductor. Similarly, in reverse bias, if we increase the voltage, this is that peak inverse value. So this is that voltage which is bear by the device, okay, which is bear by the device. So beyond that, if we increase the provided the magnitude of the provided battery, the voltage of the provided battery, then due to that electric field, the electrons, the bounded electrons will be knock out from that atoms, and due to which the current will be increased in this reverse direction. So if we increase that voltage, that provided voltage further, then the avalanche effect will be occur. In that avalanche effect, that not electrons from the atoms will, the kinetic energy of that will be increased in the reverse direction, and due to which that will collide with the neighbor atoms and knock the electrons from the neighbor atom, and hence the current will be increased. And if we if we remain that voltage for a long time, so there may be the possibility that the diode will be fire up. Okay, so it will be blasted. Okay, so this is the detailed overview of the current to voltage characteristics of the PN junction. And that's it, guys. Thanks for watching.